Welcome to Study Loop.
This problem is looking at the difference between the relativistic and non-relativistic magnetic force on a particle. So a key concept that we're going to need is the angular frequency of a particle, charged particle moving through a magnetic field, both the relativistic and non-relativistic forms. In part A, we're asked what the speed of a proton would be if it has an energy of 1,000 giga electron volts. So we know that the energy has to be equal to gamma mc squared, where gamma is equal to 1 minus v squared over c squared to the negative 1/2. So we can solve for gamma first. Gamma is going to be equal to the energy over mc squared. We should keep this in mind because we will need it later. But then we can also solve for v by replacing gamma. So if we solve for v, we should get 1 minus v squared over c squared is equal to mc squared squared over e squared, or v squared over c squared is equal to e squared minus mc squared squared over e squared, which is just 1 minus mc squared over e quantity squared. Or finally, v is equal to the square root of 1 minus mc squared over e squared times c. So using the energy that we're given, and then the mass is equal to the mass of the proton, which is 938.3 MeV over c squared, we get that the velocity is about 0.9999996 c, where I am keeping this many digits to differentiate it from 1 because it is not moving at the speed of light. It is just moving very close to the speed of light. So in part B, we're asked to find the angular frequency of a proton moving with this velocity in a magnetic field with strength 4 Tesla. And we're asked to do this both non-relativistically and relativistically and compare the results. So the non-relativistic form, which I'll call omega nr, is going to be, it's equal to the velocity divided by the radius, or it's equal to the magnitude of the charge times the magnetic field strength divided by the mass. In this case, it's EB over MP, which if we plug in the numbers for these, and remember the elementary charge is 1.602 times 10 to the negative 19th coulombs, we get that this is about 383 megahertz. The relativistic expression is slightly different. It is going to be equal to the charge times the magnetic field over gamma times the mass, which is EB over MP. And then for the gamma factor, we can use the same thing that we had from part A, where it's E over MC squared, So times mass of the proton, c squared, over the energy, or E B c squared over energy. And if we again plug in our numbers, we get that this is about 0.360 megahertz. So then comparing the two of them, you can either plug in directly or you can simplify a little bit. So we know that omega non-relativistic was EB over proton mass, whereas omega relativistic was EB c squared over E, the energy. So if you simplify this, you get E over mpc squared. So the difference between the two is going to be this factor. And if you actually plug in, or if you just use the two values we have up here, you get that the difference, or you get that the non-relativistic frequency is about 1070 times bigger than the relativistic frequency. So this is why it's important to use the correct relativistic forms for relativistic particles.